Hello all. So as a continuation of my lecture series in power system analysis, today we are going to discuss about a problem solving method called Runge-Kutta method. So this Runge-Kutta method have four ranges. That's first order Runge-Kutta method, second order, third order and fourth order. We have four different methods. So we'll see the difference between all the four. So the first order Runge-Kutta method. So first we are going to consider a differential equation of two parameters dy by dx, which is a function of x and y, and with the initial condition that x naught is equal to y naught. So by Euler's method, you might have already learnt in Max Euler's method and Taylor's series. So yn plus 1 for the next state, this is done with the help of iteration method. So yn plus 1 is equal to yn plus h into a function of xn by yn. So if we consider by Taylor series, so it is a function of n plus 1 where h into y dash n. So the function of x1 yn is mentioned as y dash because it is first order differentiation. Similarly, the second order continues by Taylor series. Coming to second order function, yn plus 1 is equal to yn plus k, where k is, we have two parameters k1 and k2 for the second function. So k1 is the function of xn y1, where k2 is the function of xn plus h and yn plus k1, or it can be written as yn plus 1. Similarly, coming to third thing, so we have three parameters k1, k2 and k3. So we have formula for k is 1 by 6, k1 plus 4, k2 plus k3. So yn plus 1 is yn plus k, that will never change, where k value alone changes based on the order of the transfer function. Sorry. So fourth order we will be having k1, k2, k3 and k4, where it is clearly mentioned like a function of x and yn, function of xn plus h by 2, yn plus k1 by 2. Similarly for k2 by 2, similarly xn plus h, yn plus k3. So these are all the basic formulas that we have to know before solving a Runge-Kutta method problem. So here we have four ranges: first order, second order, third order and fourth order. So coming to an example, in the question they have given it as solve the differential equation dy by dx is equal to x plus y with the fourth order Runge-Kutta method. So we are going to identify k1, k2, k3 and k4, where y of 0 is equal to 1 with x and h values as 0.2 and h is equal to 0.1. So given data is y of 0 is equal to 1 and h is equal to 0.1, dy by dx is equal to x plus y. This is the data given. So dy by dx can be written as function of x and y. So f of x comma y is equal to dy by dx plus which is equal to x plus y. So first order, as we all know, x naught, y naught, h, n, all the values we know, where k1 formula is h into f of x naught, y naught. So h's value is 0.01 into x naught comma 1 is 0 comma 1. So 0.1 plus 0 plus 1 will give you 0.1. So this is the equation for first order. Similarly, k2 is x naught plus h by 2, y naught k1 by 2. So just substitute the values. K2 is equal to 0.11, k3 equal to 0.1105. And similarly, we are going to solve a k4, and at last we are going to find yn plus 1, right? Yn plus 1 is equal to yn plus k. So here n is equal to 0 for the first iteration. So all the values k1, k2, k3 and k4 are known. So just substitute all the values in the last one. So in this problem, a differential equation will be given with the help of x and h values. We are going to determine the next state yn plus 1 value with the help in the question itself. They might have mentioned whether we have to solve the problem with the first order, second order, third order or fourth order. All the things will be mentioned in the question itself. So this Runge-Kutta method will be helpful in order to simplify the problem to find out the next state with one iteration. If we go with the second iteration, we have to substitute n is equal to 1 and follow the same procedure in order to find the value of yn plus 1. Thank you.